Hello class, I hope you're having a wonderful day. Today I would like to complete a practice problem from chapter 6 that covers uniform circular motion. So let's go ahead and get started. A 45 kilogram merry-go-round worker stands on the ride's platform 6.3 meters from the center. Her speed as she moves around the circle is 4.1 meters per second. So in this problem, it wants us to calculate three things. Part A, the time period. This is identified by capital T. And remember that time period represents the amount of time required for the object to make a full revolution or a rotation around the circle. Part B, centripetal acceleration. This is identified by A sub C. And then part C, the force of friction. So F with a subscript of friction. Okay, let's just draw a simple picture to help us see what's really going on here. So we have the axis of rotation. This is the center of this ride. And then we have our friend, this lady that's standing on the ride's platform at a radius of 6.3 meters for the circle. And she's going to move around in a circle, okay? So remember that this time period that we're going to calculate is the time for her to make a full rotation or one revolution around this circle. So to calculate the time period here, we're going to use the base equation for the velocity of the object. We know that the velocity of an object in uniform circular motion is the displacement vector, which is the circumference of the circle, divided by the time period. So since this is our unknown right here, I'm going to multiply by time period on both sides of the equal sign, and then I'm going to divide by the velocity of the object. So this is going to give us time period is equal to the circumference of the circle divided by the object's velocity. Now what I'm going to do is expand the circumference here, because we know that the circumference is equal to 2 pi r. So my time period is equal to 2 times pi times the radius divided by the velocity. So this is going to give us 2 pi, and the radius is 6.3 meters. And we're going to divide this by the velocity. It tells us right here that that's 4.1 meters per second. Okay, so let's go ahead and grab our calculator here. So 6.3 meters times 2 is going to be 12.6, and then times pi. So 12.6 times pi divided by 4.1. That's going to give us 9.654. So time period equals 9.654. And now let's take a look at the units here. So in the numerator, we have meters, which we can write meters over 1, divided by meters per second. And when we divide fractions, it's like multiplying by the inverse of the denominator. So this gives us meters over 1 times seconds over meter, because it's the inverse of the denominator. So we see that our meters cancel here, leaving us with units of seconds. So our time period is 9.654 seconds. Okay? There we go. Okay, next, let's talk about part B. So the problem wants us to calculate the centripetal acceleration of our lady friend. So centripetal acceleration is equal to 4 pi squared r divided by t squared. Okay? So 4 pi squared times the radius divided by the time period squared. Okay? So I've got 4 pi squared times the radius, and the radius is 6.3 meters. we're going to divide this by the time period. Now, this is the time period that we just calculated. So we're going to use this calculated value. This is 9.654 seconds. And then we're going to have to square that value. So let's just start in the numerator here. According to the order of operations, we need to take care of our squared first. So I'm going to square pi, multiply it by 4, and then I'm going to multiply that answer by 6.3 meters. So we're going to wind up with units of meters. So pi squared times 4 times 6.3 is going to give us 248.71 meters. And we're going to divide this by the time period squared. So let's square 9.654. This gives me 93.2. And we have units of seconds squared here. So in my denominator, I really want to take a look at the units here because we have a squared value for 9.654 seconds. So remember, not only are we taking the squared, are we squaring the numerical value, we're also squaring the unit value. And that's why we get units of seconds squared, because seconds times seconds is seconds squared. Okay, 248.7 divided by 93.2 gives us 2.67. 2.67. That's our numerical value. Now let's take a look at our unit value. So we have meters per second squared. So right up here, centripetal acceleration, 2.67 meters per second squared. Okay? Now, let's take a look at part C. Part C wants us to calculate the force of friction. Okay? So, we know that the velocity vector is tangent to the circle, but we have a net force that is applied to an object that keeps it in uniform circular motion, because this force vector, this net force vector, is pointing to the center of the circle. So it causes the object to continuously turn into the circle. So this object is always making a turn and accelerating towards the center of the circle. Now the agent of the net force in this situation is the force of friction. And let's think about that. Let's say our friend was standing on this and all of a sudden it's a different material, like it was standing, like she's standing on ice. Well, there's not as much friction, so she would move in a direction tangent to the circle. Okay, so this friction force is keeping our friend at a position of 6.3 meters from the center of the circle. Okay, so the net force applied is the product of our friend's mass multiplied by centripetal acceleration. So the mass of our friend is 45 kilograms. Our centripetal acceleration, so we're going to use the calculated value for centripetal acceleration, 2.67 meters per second squared. So times, and my net force, which the agent of the net force is the force of friction. This is equal to 120.1 newtons. Okay, well, I hope that this helps you today. If you need any additional help or you have any questions about your assignment, please feel free to give me a call or send me an email. I hope you have a wonderful day.